Welcome. I was just making this and thought I'd share. It's so cool. Watch this. So this is North America, of course, right here before it flashes over. Now this is Western Pacific that flashes over. So if we go to this map, here's the Western Pacific, North America. And I've been saying that they're atop one another, so I just put them atop a little more paying attention. Now that I'm like, feel like I'm picking up more on precision wise type of interpretations, maybe. That's how I'd like to see it, maybe. I don't know. Maybe. So let's check it out. So, what's going on here? I know it kind of looks like a blur. Like, what? How could this possibly be related? How could this possibly have any relationship? But so here, let's go like this. See maybe it's not exactly perfectly overlaid, but there's this contour here that matches that blue one. And then we see another blue one here, and there's a path through right there that matches that as well pretty well. So those two contours there are pretty well matched. There's also, if we look up this way here, it's kind of, maybe not exact, but like there's some kind of semblance of Florida type things. And mind you, this is going on beneath, even lower. Like maybe a good example of what I'm envisioning here is if we go to the air this time. I know sometimes and just change the height surface 10 hectopascals, and like look at say a pole here. Is this our wind? Here we go. This is it. Wind, air, wind, and we see like structure here like this. But if we go, this is very high. Then we drop down. We see the same general structure, but it's changing. Where there's similarities, but there's differences. And now it's like hard to even distinguish that there are layers that have this layer, this layer, this layer, like that they're atop one another, but there's still the general trend. Still the general trend. Still the general trend. Still the general trend. It's just getting more complex, cascading into more eddies, but still the general trend is present. So basically, like the layers below the Pacific, or below North America, the Pacific was forming below at a different depth. The Western Pacific over here, which, let's go back to the other map. This region was forming underneath it. That's the idea. So that's what we're looking at here. And then they separated by the process I've been talking about. So I tried to match the dragon segment along, and the nose comes to pretty much right here. It's not like, none of it's exactly as I'm aligning it in my other places. Like I think I put it more like there relatively in my head, and in my last video, I think. So maybe it's not exactly aligned, but so if we go up here though, right here, this arc still has an arc here. There's two arcs here, one, two. Each one has an arc shape there. And then again, here's an arc, here's an arc. And then this one just basically went in like this region is formed after the ocean opened, so it like left behind this chunk that I had an eddy, I guess, from a current coming down this way and colliding and just eddying here, colliding with this current, which it only could break in so far, I guess. But mind you, there's a current coming across here. This situation is going seemingly right at Bighorn Mountain. It's pretty interesting. Just 70 or 65 million, 66 million. It pretty much formed at the KT boundary. So it seems that Hawaii was shoved physically up this way, up through here, where it then went up to as far as it could go, and then it began to come back the other way. But I think it went up like this way through here, and then it ended up over here. And when it was over here, it then started to retreat back this way, where it went through this cross current, which then like took its material here, and maybe like literally it like exploded, and like it was rolling, and it like had a nova where it like released a lot of material in the cross current that then swept over and was just, I don't know if this is around 65 million. Emperor seamount, like 70 million. Age of seamounts. Yeah, I know it started around 80, I thought 81, 82. Let's see if we can just see an image. I know, so the bend is at 47, so that's good. Like if it's around here is around 65 million, like 80, 65 somehow around here, where it then sends this debris that goes over to Bighorn Mountain and kicks off the like KT boundary by whatever happened there that creates this like this around it, like energy flowing up in this way, crossing the current here, or actually it's probably at this boundary, because this is fanning out going this way, but it's also generally has a boundary up here that's like right there, like up here, or right there, right here, right there is Bighorn Mountain, was like in this area, I guess. Based on this, we're kind of approaching it. So if that seamount chain is dated well, that would be very interesting. Or whatever. I'm not sure it's actually a seamount chain. Just freaking so many tabs. Just open more tabs. My poor computer. Sorry, buddy. If this dates to around 65 million years, 70 to 65, that'd be really interesting. It also looks like it's generally like, if there's some sphere propagating this way, that then part of its material is exploded away by a cross current that then takes the material with it. That has a underbelly that it's flowing at here that actually is abutting here. Then maybe it would kind of put little, like, the shapes we see there of these little protrusions dependent on the shape. And then over here it gets through almost like it is in this region with those, and then it gets through here. It's not, it's before the end, and so it kind of looks appropriately placed. Like if we zoom in on this, it's pretty I'm not sure if that's it. I mean, it's pretty close if that's it. But it might be farther, like over here, and I just cut it off because I cut out anything that was basically young oceanic crust. I cut out and left a bit of it just to show it was there. Also, this is young here. Probably, I'm not sure. Like, it seems younger, like maybe Florida is composed of chunks of this material that were actually left behind. They're kind of almost like it's part of the Pacific Plate or something. The Western Pacific Plate over there. So yeah, I mean, I was just thinking about this, I guess maybe let's find some dates. Let's go to Scholar. Hawaiian Emperor Seamount Chain. See what we got. Maybe we can find names. I mean, I could read this a bit. This might be more focused on the bend. I'm just kind of curious what this is about. It says 80. 80. Like, did it go that far almost instantaneously? And then 47's the bend, 10, 0. So it seems like some type of motion seems to, or is it red is the Pacific Plate motion, yellow is the chain. Let's just find something. Okay, Coco? Nintoku. Maybe like from here where it goes down to here. Okay. Can we find ages for those ones? Like, they must individually have ages. Okay. There's seamount chain. Seamount. Ages. Let's see. Cocoa. Cocoa. Why don't you let me search Cocoa? Oldest ages. Oldest measured ages. Figure 2. North of Cocoa. Too young. Cocoa. Maybe 50. Cocoa. Only 92 and 82 million ages for samples from 2 volcanoes located close to Pearl and Hermes. Older Wentworth sea chain, which intersects the Hawaiian chain. Wentworth. I've never heard of that. Qu'est-ce que c'est? Set? No. Set? Wentworth. Sea chain. Is that the name? Wentworth. Okay, figure 2. Cocoa. Distance, not age. Age. Cocoa. 52 about. Nintoku. 55. Swicko. 62-ish. Interesting. How far back? All the way back here. I mean, I guess that is actually in line with something. I don't know why it would be. Let's see. This. Diamond. I was like, where's that diamond? Diamond is related to this current coming across this way from the mantle puncture hole, going across above this, going across here, hitting this current coming up here, and then going down and up and separating like that. Up, down, interact with the sphere as it goes down. Down, up, interact with the sphere as it goes down, which maybe brings down some material. I don't know why that would like kick off the KT boundary specifically. see what their conclusions are. Between overall hotspot motion of as much as 719 kilometers between approximately 75 and 47. 47.5. I was going to say 475 like over and over. Rapid motion between 55 and 50 as fast as 101 kilometers per million years. Which is, interestingly, when this Silesia fireworks he's talking about in this video.
We have Pluton.
44 to 55. Where something's coming in this way, bringing material here. That's then volcanically erupting. And also seamounts. He's calling it a seamount. Like a Silesia seamount. Coming in this way, mind you, if we follow this across. It's kind of tough because it isn't really continuous. It starts to go down. It goes down this way. But it's still initially, before it opened, like, points at it. It points at it. And then it just opens space between. But initially, this flow is going into this location, like from across here. We can find a boundary here or here and just follow it across here to here. Which was here to here, pretty much. Although that doesn't... It flows weird. If this is there... It just flows weird. Huh. Could it be this current going up this way? Turning here? Which maybe like went up this way for a time, and then over time it ended up like gaining space so that it ultimately had a... I don't know why I would do that, but... Certainly related. Certainly related. 100%. Alright, I'll be back soon. I don't know when. I know I also, like, recently... I make so many videos where I just kind of complain too much. My bad. Hugs. Mucho lavos. Au revoir, mon ami.